Hello and welcome to a video going through the GCSE Maths Mock Paper 1 questions 1 to 11. Okay, let's get on with it. Ali and Beth divide 280 in a ratio of 2 to 5, so you probably got this one right. We just need to add the ratio together because we know it's 2 parts to 5 parts, and so the total is 7 parts. There's lots of ways of doing this really. Let's let's do 280 divided by 7, which is 40. So that's telling me that I need to scale this up times both sides by 40. 2 times 40 is 80. 5 times 40 is 200. And now, sure enough, it adds up to 280 and it's in that ratio. So Ali must get 280 and Beth must get 200. Try and avoid getting those kind of things wrong because obviously it's a nice easy mark question. Now, question 2, look at this, 5 marks. That means you must give reasons for your working. Don't even try and not give reasons for your working. And I mean, okay, sometimes students think, well, how many reasons? Give at least 3 reasons. For a 5 marker, you want to have 3 reasons in there. And use mathematical notation. You'll be winning friends with the examiner, which is exactly what you want to do. Right. Find x here, noticing that these two sides of the triangle are isosceles. Okay, we can say angle ABE, and that's clearly this angle in here, which I'm talking about, is 180 minus 142, which is 38. Yeah. Now let's just justify that for a second and say angles on a straight line. Now, at the moment, that's not good enough. I know you're thinking, wow, they're really strict, yet they are. If you just say angles on a straight line or something like that, they won't allow it. You have to say add to 180. Yeah. So you're justifying your working. Why not put it like that? And it's nice and clear. Each statement should have a justification with it. Okay, now write that on the diagram, 38. Now, lots of ways you can proceed from here as well. If that's 38 and this is an isosceles triangle, well, both these sides are equal. Yeah, so we could call them A and A. And we can just say angle, well, writing it in their notation, angle BAE plus angle BEA equals 180 minus 38, sorry, which is 142. Yeah, and how are we going to justify that? Well, it's base angles of an isosceles triangle. Are equal. That's what I'm going to do next anyway. I haven't actually done that step yet. Are equal, and that's why I'm going to divide this figure by 2, so I know what each one of these is. So yeah, let me just put it like this: as BAE equals BEA, then BAE equals 71. And really, we've cracked the question there, haven't we? Because we know that that's 71 and that's 71. But you can in fact use the fact that that's a Z angle in there. Can you see the Z angle? Like that. And therefore X is 71 by alternate angles. Yeah. Thus, X equals 71. You can just put alternate angles are equal. And you can even put the angle it's alternate with, if you really are paranoid, which is BAE. BAE is alternate with angle X. Alternate angles BAE and X are equal. It's all about just explaining what you're doing. Sorry about my handwriting as well. It's poor. Okay, right, that's that one. Right. The perimeter of a square is the same length as the perimeter of a triangle. I was quite surprised actually how many people slipped up on this with the ones I was marking. It's not a bad question. It really isn't. And please use the equal sign and use justification. Explain what you're doing. So we've got to find an expression in terms of x for the length of the side of the square. Okay, the perimeter of the square is the same length as the perimeter of this triangle. So let's just do it like this, perimeter of the triangle. Okay, that clearly equals 2x plus 3. Notice I've used an equal sign. Yeah, I'm telling the examiner what's going on. Plus 5x minus 2 plus 5x plus 3. Now just make sure you don't make a mistake with any of the signs. Chop it up like that if you need to. Yeah, the sign is sticky with a number in front of it. And then you can actually do 2x plus 5x plus 5x, 12x. And then 3 minus 2 is 1 plus 3 is 4. Yeah. Okay, right, find an expression in terms of x for the length of a side of the square, and the square has the same perimeter as this, yeah? So the perimeter of the square is 12x plus 4, and therefore the side of the square is going to be 12x plus 4 divided by 4, which can of course be simplified into 12x divided by 4, 3x, and 4 divided by 4, 1. And that's the final answer, 3x plus 1. And that's why they're saying give it in its simplest form, because they don't want it left like that. Okay, number 4. This one, the swimming pool one. Be careful with this as well. Chop it up whichever way you like, but just make sure you know what you're doing. I'm going to chop it like this. Yeah, clearly we're going to have to find the volume of this at some point, and it's one of these the water is filling at a rate questions, so it can be difficult. There's no doubt about it. Okay, right. Now what's the distance here? It's 5, we can see, because 15 minus 10 is 5. It's good to annotate the diagram. This distance is 2. Yeah. Okay, so we've got a cuboid with like a triangular prism at the bottom. Yeah, and we know all the lengths of everything. Now remember, don't forget to halve with the area of a triangle. That's a classic mistake in these kind of things. So the volume of the pool. Okay, V pool. I'm telling the examiner what I'm thinking, what I'm doing. 15 times 10 times 1. That's the cuboid accounted for, if you like. That's all of that. 15 times 10 times 1 plus 5 times 2 times a half finds you the area of the triangle. And then it's a prism, so you need to times by 10. Yeah, so just try and get all of those details. It's easy to miss something, we've all done it. It's easy to do. So that's 150 plus 2 times a half. Right, just cancel those out. Now you've got 5 times 10, 50. And so the volume of the pool is 200. Yeah, okay, great. I found that out. Now, there's a number of ways of doing this question because we've got to decide, basically, she's got 10 hours to fill the swimming pool. Yeah, we now know, of course, the volume of the swimming pool in meters cubed. Yeah, now 1 meter cubed is 1,000 liters. That's very nice of them to tell that, say that to us. They don't have to give you that information, I don't think, anymore. They could just expect you to know that a meter cubed is 1,000 liters. So bear that in mind for the real test. So this is obviously, 200 with 1, 2, 3 zeros on the end. So that's 200,000 meters cubed, liters. I've just converted it to liters. So that's nice. Okay, so I know how much I've got to fill it. Now, what's the score here? 10 hours to fill the pool, 5 liters per second. Yeah, so 5 liters, in 1 second. So how much is done in a minute? I like scaling it up like this. In a minute, it's going to be 5 times 60, which is going to be 300. And then in an hour, where it's going to be 300 times 60, which is 18,000. Yeah. Obviously, this is a non-calculator paper as well, so you've got to be kind of careful with, as you do this. This is not easy to do when you're doing it without a calculator, isn't it? Times by 60, times by 60. Just check you've got enough zeros here. We need 3 times 6 is 18, and then 1, 2, 3 zeros on the end. Yeah. So that's how much is done in an hour. Now she's filling it for 10 hours, is that right? So I'm just going to work out what's done in 10 hours. So in 10 hours, it's 180,000 litres. So can he completely fill the pool? No, he can't. He can't fill the pool in 10 hours. In fact, I could say he can only fill 90% of it. You don't have to say that, but just to show that we know what we're talking about. Cool. Okay. Ooh, I don't know what's happened there. Let's zoom back in. So yeah, that's that one. It's not really that bad as long as you maintain calm. And there's loads of ways of doing it as well. If you did it a different way, you can certainly find, for example, how much is filled in 10 hours. Well, sorry, that's the way I did it. Or how much he would take in hours to fill it, and it's like 11 hours or something. But yeah, there's lots of ways of doing that one. Okay, right. It takes 12 men 5 days to do a job. Yeah. Work out how many days it would take 3 men to complete the same job. Well, 12 men, 5 days. We can assume that work, like, more people means shorter work, less people means longer work, yeah? And we're assuming that it's inversely proportional here in a direct sense, directly inversely proportional, if that makes sense. I'm not sure it does. Okay, 12 men, 5 days. That means it's going to take 1 man, divide by 12 here, times by 12 here, 60 days. Cool. Okay, so how long is it going to take 3 men? Well, divide by 3, 20 days. Looks good to me. That's good. Okay, 20 days. Do make sure you write down your units. It's like state one assumption I made that all men are working at the same rate. something which gives them that idea. I think I even gave the mark to a girl who said that all men were as strong as each other, were of the same strength. I don't know quite what was in her mind when she was doing this question, but yes, I reluctantly accepted that. Okay, how will your answer be affected if your assumption is not correct? Well, this is annoying because, I know in the mark scheme they want you to say something like this, but they should be more precise in their question. I think the question is poor, but you may have to deal with a poor question. Put more detail down. That was my main problem with this. Yeah, you can't just say, well, then it's going to be a different answer because yeah, of course it is. They want the direction though, so you want to say something like this. If this assumption is not correct and all men are working at the same rate, well, you can say something like, if most men were working at a slower rate, it would take longer, or something like that. Yeah, they want you to get an idea or give them an idea that you understand that, like, if they're working at a slower rate, the whole task is going to take longer or something like that. I think that's what they were looking for. Let me have a glance at the mark scheme. I've got it next to me. Hang on. If rate slower, it takes longer. Rate faster takes less time. I needs to refer to how the rate changes. Yeah, they're looking for you to really show that you understand how the rate changes, the time changes. That's all. But be more detailed with that. But I do understand your kind of like frustration with questions like that, where you kind of feel like you've got to guess what's in the examiner's head. Like they should be more precise in their questions. Anyway, number 6, probability tree. Okay, right. Is it a fair dice? Red dice 1 to 6, blue dice, 1 to 8, so it's an octahedron. Okay, Graham is going to roll both dice. So red dice, probably it lands on a 6, surely 1/6. Blue dice, don't get excited, they're not normal dice. The blue dice is an octahedron, and so you need to, probably it lands in a 6 if 1 in 8, and 7 in 8, and 1 in 8, and 7 in 8, because there's 8 possibilities on an octahedron. So it's easy in the heat of an exam to miss that sentence, but read it carefully. So we've done the tree, work out the probability that neither dice will land on a 6. Well, not a 6 and not a 6. That's going to be 5 6 times 7 eighths, which is, of course, 35 over 48. And that is the final answer. Okay, next question. Oh, quadratic sequence. I love a quadratic sequence. We know it's quadratic anyway because it goes plus 3, plus 5, plus 7, plus 9, plus 11. And then plus 2, plus 2, plus 2. Okay, right, which way do you want to do this? Well, I tell you what, I've started to come around to the idea that maybe the approach where you use a lot of algebra, nth term equals an squared plus bn plus c, this approach, maybe I'm coming around to this approach. If we just now plug in the first term, well, we know that when n is 1, first term, if you like, we know that a times 1 squared plus b times 1 plus c, well, that equals 3. In other words, a plus b plus c equals 3. With the second term, we can get a similar equation, but we're going to get 4a plus 2b plus c this time, because n is 2, and that's going to equal 6. Yeah, and I'm really interested in this equation, and I'm interested in this equation, because there's going to be simultaneous equations. Yeah, by the way, right now, I can quickly take these equations away, and it gets rid of the c. So I can see when I take these away, I get 3a plus b equals 3. Yeah. Okay, let's find the third term. Yeah, last one we've got to do. Well, that's going to be 9a plus 3b plus c, and that equals 11. And now if I take this away with the first one, I get 8a plus 2b equals 8, and therefore 4a plus b equals 4. Solving that with that, subtracting, we get a is 1, and then b, if a is 1, let's have a look and plug these back in, we're going to get b is 0. That's interesting. And then if a is 1 and b is 0, we're going to get 1 plus 0 plus 2. And so this must be n squared plus 2. And at that point you realise, silly Billy, we should have just realised that straight away because they're all 2 more than square numbers. Yeah. I must admit I didn't check that. Probably should have. I can't remember. I marked this last week, so I've already forgotten every question in it. Okay, find the 50th term of the sequence. Well, that's just going to be 50 squared plus 2. So 2502. Okay, next one. 2 3/4 times 3 1/5. Well, turn it straight into top-heavy fractions. 2 times 4 is 8 plus 3 is 11. 3 times 5 is 15 plus 1 is 16. Yeah, they're now in mixed fractions. Do something like this. It's well worth doing. It makes it easier. So you just get 44 over 5. And there we go, we've got it, 44 over 5. You don't have to convert it back into a mixed fraction. You really don't, which is nice. You can just leave it like that. Okay, next one. What we got? One of these density. Is this about mass and density? Mass, volume there. No, it's just about mass and volume. But it looks like one of these awkward ratio questions. I'm always slightly wary of the later questions on ratio which appear in the later part of the paper. They can be really difficult. Okay, right. A liquid R is made by mixing a volume of liquid P with a volume of liquid Q in the ratio of 3 to 7. Yeah? Okay, right. And P has mass P grams. That seems sensible. And Q has mass Q grams. Find an expression in terms of P and Q for the mass of 50 litres of liquid R. Right, okay. So I'm just going to write down the question and remind myself that that is P to Q. Yeah? And I've got to find an expression for the mass of 50 litres in liquid R. Well, if I think about liquid R, it's got 50 litres, yeah? 1 litre is P grams, so 50 litres would be 50P, yeah? 1 litre is Q grams, so 50... Oh, hang on, but I don't want to be doing that because let's think about it. If I've got 50 litres of liquid R, yeah, we can split that into... Yeah, let's do that in the ratio. So this is 10 parts. Yeah, we want it in 50 parts. So if we times by 5, we can see it's 15 to 35. Yeah, let's get that sensible ratio in there. So what I know now is that I need 15 litres of P and 35 litres of Q. And we want an expression in terms of P of Q of that. So 15P plus 35Q. And that should give us, because that is the litres here and the litres here, that should give us the an expression, sorry, there. That's how much mass there is, I should say, in that many litres. Because we need 15 litres of P and 35 litres of Q. Well, the mass of 1 litre is P grams, so we need 15P. And the mass of 1 litre of Q is Q grams, so we need 35Q. And you've got your answer. There we go. It's not as bad as it looks, that one, is it? I was, I'm always wary because they've come up with some really tricky ratio questions recently. Anyway, okay, right, 10. The area of rectangle B is 10% the area of rectangle A. Okay, right, yeah, I would like to look at this one. So times by 1.1 on that area, and you get that, yeah? And the area of rectangle C is 10% greater than the area of rectangle B. So if you're going from here to here, yeah, you need to times by 1.1 twice. In other words, you need to square it. And 11 times 11 is 121. So 1.1 times 1.1 is 1.21. So by what percentage is the area of rectangle C greater than the area of rectangle A? 21%. I'm almost worried there for the 3 marks that I'm not going to get enough marking. Let's have a quick look what it says in the mark scheme. P1, starts process, e.g. use of 1.1. Okay, well, I've got that. Another P1 for complete process, derivation of 121% or 1.21 or equivalent, and then just the correct answer here. So yeah, they would give me it for that. Good. But yeah, you just need to square 1.1. Okay, right. Cumulative frequency. On the grid opposite, draw a cumulative frequency graph of this information. Right. First things first. Plot on the endpoints. Only for cumulative frequency, yeah? If you're doing a normal line graph, you do it on the midpoint, definitely, yeah? But there's one exception to when you don't do it on the midpoint, and that's when you do it on the endpoint, and it's when this word is used in the question, cumulative frequency, yeah? That's when you plot on the endpoint. So forget 0 to, we're basically going to be using these figures for where we plot, yeah? So 0, 10, plot it on 0, 10. This is going to take a while doing this. And it's going to move as well. Let me put it next to it. 1 second. This might make things easier. That's better. Much more sensible. Okay. So let's get rid of that one because that's slightly in the wrong place. Try and be precise on these things as well because they do have tolerance in the answer, but they're not mega tolerant. Okay, 20 I've got to put on 7. Make sure you plot it right. I'm not very good at this. 30 you've got to plot at 20. My eyes used to be better. 40 you've got to plot at 64. blimey, right the way up here. It's 1 per square, isn't it? 61, 62, 63, 64. I admit the graph paper on this test as well is rather crazy. It doesn't look right. Okay, and then 50 is 74. And finally, 60 is 80. So it goes right the way up there. So we get a really steep curve. By the way, I recently found out if you want to join the dots with a ruler, they accept that in Edexcel. I was really surprised to learn this, but they do accept it in Edexcel. I'm going to check in here if it says the same thing. No, it doesn't mention it actually, but I've seen it before on the notes. I think it might have been for I think it was a GCSE paper. I'll hunt it down again because I'm quite interested. But I believe it's absolutely fine to join the dots when you're doing that. And I never used to realise that. I never used to join the dots. I used to be wary. But it's easier for students if they can just use a ruler. So if you want to join the dots, you're fine. Okay, right. Jane expects that it should take her X minutes to go home from her home to school each day on the 25% of the days last term. Jane took longer than X minutes to go from home to school. So she took longer than X minutes. Yeah. So that means she was pretty late. Yeah. Use a graph to find an estimate. Yeah. Well, the 25% of the time when you take longer, well, firstly, 25% of 80 is 20, and then you need 3/4 of that, 60. You're going to find here you need to go from there to there and go down. Yeah, let's see if I can get it right even with my really poor effort here. I'm getting a value of about 39 there. Yeah, they would have accepted any answer from 37 to 39 apparently. Yeah. By the way, in terms of showing the working for that, make sure with your ruler, show those dots on the diagram, yeah? They love that kind of stuff. They will see that evidence of reading from the graph from 60, yeah? You have to have these dots to get the mark, like put them on there. Don't do it without. Okay, and that's it for the first part. I will do the second part in a second though.